So let me do this example. Okay, decide whether the vector field F, whose components are xy minus sine z I plus 1 over 2 x squared minus e to the power y over z j and e to the power y minus over z squared minus x times cosine z k is conservative in the domain D x, y, z in R3 provided that z is not 0. And find a potential for F if it exists. Yani konservatifse bir tane de potential bulmak istiyoruz. Peki yani conservative demek so we look for a function phi x, y, z so that f is equal to gradient of phi. So phi sub x, phi sub y, phi sub z. So this means what? Phi sub x is just f1, which is x, y minus sine z. Değil mi? Yani şurada işte bunun ilk komponenti f1 bu. Phi y f2 o neymiş? 1 over 2x squared minus e to the power y over z. 1 over 2x squared minus e to the power y over z. And phi z f3. And what is f3? E to the power y over z squared. E to the power y over z squared minus x times cosine z. X times cosine z. Şunu yapıyoruz. We are given this vector field F in 3 space. It is defined everywhere except the z coordinate, except the points where the z coordinate is 0. Okay. So except the xy plane, actually. It is defined everywhere except the xy plane. We are asked to find a potential for this vector field if it exists. I mean, if there is a potential. So if this is conservative, we are asked to find a potential. Potential means a function whose gradient is equal to f. So components of f, which are these functions, right? This is f1, this is f2, and this is f3. So this will be phi sub x, phi sub y, and phi sub z. So we are looking for a function whose partial derivatives are these objects. How can we find such phi? Well, let's start with this equation. Phi sub x is equal to this. Well, if phi sub x, so if phi sub x is equal to xy minus sine z, then what is phi? Phi is the antiderivative of this with respect to x. So I just need to take its integral with respect to x, keeping in mind that in that case I regard both y and z as constants. So derivative integral of this will be just x squared y over 2 minus x times sine z plus a constant, right? If this is an antiderivative, there should be a constant. However, I regard y and z as constants. Therefore, this constant function, whatever it is, it may have y and z in it. Okay, so there is some h for, there is some h which satisfies this. H is to be determined, where h, y, z to be determined. Değil mi? X'in dışındaki her şeyi sabit olarak gördüğüme göre sabit dediğim şey genel olarak y ve z'nin bir fonksiyon olabilir. And then how can I find h? Well, I take this and plug into the second equation, which tells us what? Phi sub y is equal to f2, which is 1 over 2x squared minus e to the power y over z. Well, this gives me what? So I'll take y derivative of this and equate it to this guy. What is the y derivative of this? Well, it is just x squared over 2 minus y derivative of this is just 0 plus y derivative of h. So del h del y. And this should be equal to 1 over 2x squared minus e to the power y over z. Alright. Well, from this, you see x squared over 2's are cancelled. So we get del h over del y is equal to minus e to the power y over z. So whatever h is a function of two variables and its y derivative is this. So what is h, y, z then? I need to integrate this with respect to y, keeping z as if it's a constant. So what is the integral of this with respect to y? Well, it is just e to the power y over z plus a constant, right? I'm taking antiderivative, so I need to add a constant. But this time, constant can have also z in it. Therefore, this is just, let's say, g of z. Okay? İki değişkenli bir fonksiyon. Y ve z olacak içinde ve z'ye göre, özür dilerim, y'ye göre türevi e üzeri y bölü z olacak. Başında da eksi işareti var. O zaman o fonksiyonun genel hali budur. Of course, for some g sub z to be determined. How can we determine g? Well, I use this equation. I use this one. Now I need to use this one. So, to determine gz, we use the last remaining equation, namely neydi? Phi sub z equals e to the power y over z squared, e to the power y over z squared minus x times cosine z. X times cosine z. Okay. Well, uh, now phi was what? Phi was, of course, here where uh, what is phi x y z? Phi x y z is this. Uh, x squared y over 2 x squared y over 2 uh, minus x times sine z uh, plus hy. But hy is equal to this gadget. So it is e to the power uh, minus e to the power y over z plus gz. Okay. Değil mi? Peki şimdi bakalım bunun türevi neymiş? Phi z derivative of this with respect to z. First term gives me 0. Minus x times derivative with respect to z, just cosine z, minus derivative with respect to z. It will be e to the power y z squared plus g prime z. And this should be equal to e to the power y over z squared minus x times cosine z. If I compare these two, you see they're all the same. So g prime z is just 0. Now g is a single variable function of z, and its derivative is 0. It means g of z is indeed a constant. So g of z is just c, a constant function. Değil mi? G tek değişkenli bir fonksiyon ve türevi 0, o yüzden gerçekten bir constant. O halde phi'yi bulduk. So what is phi x y z neymiş? X kare y bölü 2 eksi x çarpı sinüs z eksi e üzeri y bölü z artı c. C nedir? Any real number. So we have not only one actually potential, we have many potentials. Any c value gives you a potential. Okay? So we have uh, infinitely many. We have one potential function for each C in R. Peki bir örnek daha yapalım. İşlerin biraz ilginçleştiği bir örnek. For xy different than 0, 0, consider the vector field f. Yani bu nerede tanımlı? R2 minus 0, 0. Değil mi? Orijin dışında tanımlı. And it takes values in R2, of course. So it's a plane vector field given by fxy. It is this one. Minus y over x squared plus y squared I plus x over x squared plus y squared j. Okay. find a potential for F if it exists, if there is any. Yani deminkinin aynısı, tamam mı? So potential varsa, so we need to find phi nerede tanımlı olacak? This should be also defined everywhere except 0, 0. It's a function. It should be a function so that phi sub x is equal to f1, which is minus y over x squared plus y squared, and phi sub y is f2, which is x over x squared plus y squared. Okay, now, so let's see if there is such a function. What is phi then? X derivative is this, right? X derivative is minus y over x squared plus y squared. What is phi xy then? Bu neyin türevine benziyor? Y kareyi dışarı alırsanız 1 bölü x kare eksi y kare olacak. Değil mi? Şöyle yazayım bunu. Y kareyi dışarı aldığımızı düşünelim. Eksi 1 bölü y bölü 1 artı, pardon, x'i dışarıya alalım. X'i dışarıya alalım. Yok. Y'yi dışarı alacağız. Burada x'i dışarı alsaydım. Şundan başlayayım. Yani her iki türlü de olur da daha kestirme yapmak için bunu yapıyorum. Çünkü cevabı bildiğim için. X'i dışarıya alalım. X kareyi. 1 bölü x 1 artı y bölü x'in karesi. Okay. Well, if you look at this carefully, so you see I need to integrate this with respect to y. Well, if you let u to be y over x, then du is just, so my variable is y, so it is just 1 over x times dy. So this is like derivative of y over x with respect to y divided by 1 plus y over x squared. So this should be just arc tangent y over x. Right, when you take derivative of this with respect to y, you get exactly this expression. Plus, of course, some function with respect to x, because I am integrating with respect to y. Therefore, there should be some h here, function of x, for some h of x to be determined. How can I find h? Well, we have to look at the other equation. Then phi sub x is equal to neydi? F1, which is minus y over x squared plus y squared. And this gives me what? Well, derivative of this with respect to x. Derivative of this with respect to x is what? içinin türevi x'e göre eksi y bölü x kare bölü tanjantın türevi, o da 1 bölü y bölü x'in karesi ve bu neye eşit olmalıymış? Pardon. Plus h prime x, and this should be minus y over x squared plus y squared. Well, from this we see that, you see, the first expression here is just minus y over x squared plus y squared, plus h prime x is minus y over x squared plus y squared. And from this we see that h prime x is just 0. So h of x is a constant. Is a constant function. Hence phi xy should be the following. It is tangent inverse y over x, tangent inverse y over x plus a constant. Okay. If you take derivatives of this with respect to x and y, you really get that. So hence thus, okay. Thus şöyle yazayım. Thus f is equal to gradient of this function, which is just tangent inverse y over x plus a constant, or is equal to this one. Note that okay, which is defined on R2 minus y-axis. Because you see, when x is 0, this expression is not defined. Indeed, this is just theta, right? Theta xy, which is tangent in y over x. Çok yaşa. It is this function. Siz bana bir xy point verdiğiniz zaman, değil mi? Bunun şuradaki açısını veren fonksiyon. Başka bir şey değil. Bu tabii ki x'in 0 olduğu yerde tanımlı değil. Çünkü orada y over x infinite oluyor. Dolayısıyla şunu elde ettik. F bir şeyin gradient'ı, ama o gradient olan nesne, since f is a function from R2 minus 0, 0, and phi, not phi, theta, pardon, yani bu phi fonksiyonu aslında theta'ymış. Phi, which is theta xy, which is tangent inverse y over x, is defined only on R2 minus the y-axis, yani x'in 0 olduğu yer. F is not conservative on R2 minus 0, 0. Değil mi? Elimdeki fonksiyon Yani bir fonksiyon bulduk. Onun türevine eşit ama bu fonksiyon bütün bu şeyde tanımlı değil. Yani benim f fonksiyonum şurada tanımlı. My f is defined everywhere except origin. Okay? But my function phi is defined only here. It is not defined on the x-axis. Yok. Y-axis, sorry. It is defined everywhere but the x-axis, y-axis. Yani dolayısıyla f gradient phi'ye eşit ama bu bütün R2 eksi orijinde tanımlı değil. O yüzden de f konservatif değil. Peki buradaki sıkıntının nedeni de şu aslında. If you look at what's going on carefully, this phi which is theta which is tangent inverse of y over x. This function cannot be even continuous on R2 minus 0, 0. Hani bu fonksiyon yok dedik ama gerçekten de bu continuous değil. Neden continuous değil? Why is that? Well, see. For example, what is, suppose this is the point xy. What is phi xy? Phi xy is this angle, theta, right? Xy. This is phi xy. It's a positive number. Let's say this is like pi over 3, 60 degrees. At this point, okay, at this point, theta is pi over 2. At this point, theta is pi. At this point, theta is minus 3 pi over 2. No, 3 pi over 2, not minus 3 pi over 2. Değil mi? I am just going in this direction. And then it's almost 2 pi, right? And when you come to this point, theta is 2 pi. But originally, when you start from this point, theta was 0. So you start with theta with 0, and then if this function were continuous, then it would increase, right? Pi over 3, pi over 2, pi, 3 pi over 2, and then it's going to 2 pi. So at this point, it takes two values, 0 and 2 pi. Therefore, this cannot be a function, okay? That's the reason. So my vector field is a gradient of some potential function, but that potential function is not defined everywhere the vector field is defined. It is defined on a subset. That's why f is not conservative. Gerçekten de bu fonksiyon konservatif olmadığını da görüyoruz, değil mi? Yani gravitational vector field konservatif. Neden? Çünkü işte yukarı çıktınız, aşağı indiniz veya aşağı çıktınız, indiniz, yukarı çıktınız. Aynı yere geldiğinizde, aynı seviyeye fonksiyonun değeri aynı oluyor. Ama burada öyle değil. Dönüp geldiniz, fonksiyonun değeri 2 pi kadar artmış oluyor. Bir tur daha atarsanız 4 pi olacak. Dolayısıyla bu bir fonksiyon değil. Diyeceksiniz ki peki böyle başka şeyler var mı? You may ask the following, you know, okay, this function, this vector field uh, uh, has a potential only defined on a subset, okay, not everywhere. Are there such vector fields other than this one? Well, actually, basically this is the only vector field. Let me say it as a remark. It turns out that okay, ilk önce şunu söyleyeyim. Note that f the above vector field f, okay, which has two coordinates f1 and f2, and this is defined on this, satisfies this criteria: del f1 del y equals del f2 del x. The necessary uh, necessary criteria uh, for being uh, conservative. Yani konservatif olması için ne gerekiyordu? İlk ifadenin y'ye, ikincinin x'e göre türevi birbirine eşit olacak. F1 şuydu. F1 was minus y over x squared plus y squared. F2 is x over x squared plus y squared. And if you take derivative of f1 with respect to y, you really get what? Let's see what we get. Derivative of y, I am taking derivative with respect to y. So minus 1 times x squared plus y squared uh, minus another minus plus y times derivative of this with respect to y, which is just 2y, divided by x squared plus y squared squared. So this is just y squared minus x squared divided by x squared plus y squared squared. And you can check that this is indeed x derivative of f2. Bunun da x'e göre türevini alırsanız tam olarak bunu göreceksiniz. Okay. Ama halen, however, this is not sufficient for f to be conservative. Yani o necessary condition is not sufficient. So the necessary condition, in other words, the necessary condition that del f1 del y is equal to del f2 del x is not sufficient. Yani bu koşul gerekli ama yeterli değil. Tamam mı? Buradaki problem göreceğiz ki şeyden kaynaklanıyor, geometriden. Onu remark olarak yazayım. In the next lecture, we will see that this happens because of the topology of the domain, the vector field is defined. So it's the more like geometric condition. What is that? Problem şu. Bizim vektör field'ımız, so our vector field is defined everywhere except the origin. So it is R2 minus 0, 0. Okay. This object is quite different than this one. There is only 1 point difference between the two, but they are geometrically or more generally topologically very different objects. The reason is that here we have so-called the function theta, a multi-valued function, and actually that gives us a differential form or a vector field which satisfies the necessary condition for being conservative, but it is not conservative. So this actually gives me existence of theta xy. Ama R2'de delik olmadığı için no such theta exist. O yüzden işte birinde o vektör field konservatif oluyor, diğerinde olmuyor. Mesela göreceğiz ki R2'de o necessary condition'ı sağlayan her vektör field konservatif. We will see also that on R2 any vector field satisfying del f del f1 del y equals del f2 del x is indeed conservative. Yani R2'de böyle bir patolojik durum olmayacak. Denklemleri sağlıyorsa F1 ile F2 otomatikman konservatif. Ama R2'den bir nokta atarsanız işte böyle teta gibi bir nesne var. Bu size o denklemleri sağlayan ama konservatif olmayan bir vektör field veriyor. Bunun güzel tarafı şu. Bu nesne y ekseninde tanımlı değil. Ama türevlerini aldığınızda tanımlı hale geliyor. Nedeni de şu. Bu fonksiyon multi-valued, yani kabaca şu y bölü x, ama bir tur atarsanız 2pi geliyor. Bir tur daha atarsanız 4pi geliyor. Bunun türevlerini alırsanız bunlar constant olduğu için onlar yok oluyor. Dolayısıyla kendisi multi-valued bir nesne. Birden fazla değer oluyor ama türevleri single valued. O yüzden de bu nesne siz söyleyin, böyle patolojik bir şey veriyor. Patolojik nesne vermesinin nedeni bu uzayın içinde delik olması. Gravitational vector field de öyledir. Değil mi? Orijin delik var orada. Ama o konservatif. Bunun gibi değil. Ama R3'te de böyle patolojik örnekler var. Yani eğer orijin atarsanız gravitational vector field onlardan biri değil. O çünkü konservatif, ama bunu atarsanız burada da öyle patolojik bir örnek var. Denklemleri sağlar ama konservatif değil. Bunu bir dahaki ders yapacağız. Okay, let's stop now.